Welcome to Earth Expeditions, our time to tell you about all these fantastic things. Hey, Tom!
What do you think?
I like it.
I'm ready to go to the Great Barrier Reef.
Me too, I got my snorkel.
Guys, we're not going to the Great Barrier Reef.
You said we were going in the ocean this week.
We need more emotion.
I thought you said grab your wetsuit. We're going to go study coral reefs in the Great Barrier Reef in Australia.
All right, I guess we're stuck here again.
Yay, we're back in the studio. We'll still tell you about all the really cool research that's happening in the Great Barrier Reef, Southern Africa, and Greenland through our technology like video cameras. Welcome to Earth Expeditions. At NASA, we know our world is changing.
And we're on it, in the field, up in the sky, in the ocean, and on the ground, basically all around.
From the Great Barrier Reef to the clouds above Africa to the receding glaciers of Greenland.
NASA Earth scientists are collecting the data to help us understand how the world is an interconnected system and how we can improve our lives.
Southern Africa produces almost a third of the world's vegetative burning, which sends smoke particles up into the atmosphere, where they eventually mix with stratocumulus clouds over the southeastern Atlantic Ocean. Our team, observations of clouds above aerosols and their interactions, or oracles as we call them, is checking out clouds above Africa with some pretty amazing aircraft.
My name is Jens Redeman. I'm the principal investigator for the Oracles project, and I work for the NASA Ames Research Center in Moffett Field, California. The Oracles missions is a 5-year project in which we're going to fly 2 research aircraft in 2016 and 1 research aircraft in 2017 and 18 each from Namibia to study the interaction of biomass burning emissions and low-level clouds over the Southeast Atlantic. There's a long list of reasons why we're working here in Namibia. The ER2 aircraft that you see behind me actually requires a very long runway and a large hangar so that the instruments can be opened up and properly maintained after each one of their flights. It's also the only access point to the Southeast Atlantic, really, from which we can fly and reach far into the Southeast Atlantic basin. So we're studying a very unique system. The low-level cumulus clouds are not unique to the Southeast Atlantic, but the fact that they're coexisting with biomass burning emissions at altitude is very unique to the Southeast Atlantic and gives us the opportunity to study the interactions of aerosol particles with these clouds. These interactions actually are some of the largest remaining uncertainties in how humans affect climate. We think that the data is useful in 2 ways. First off, there are really no observations of these aerosol particles in the Southeast Atlantic because they usually overlay these very bright clouds. And the satellite information that we gather don't quite give us all the details that we need in order to study their effects. The other thing is that these effects in interactions between aerosol particles and cloud particles really go on globally. And climate modelers struggle mightily with parameterizing them and putting them into their global climate models. So implicitly, we hope to have an impact on the predictions of future anthropogenic impacts on climate. Namibia has been most welcoming. We have been welcomed with open arms. The infrastructure is terrific. The airport has been recently renovated and gives us perfect infrastructure, really. But it's really the welcoming by the university and research types in the country that has made this a little bit special. We're very excited to be here. Pulling off a research effort halfway around the world is always difficult, and we've finally been able to do it with a lot of support from Namibian government entities and a lot of local researchers and support, and we couldn't be more excited to be here.
Yeah, the Oracles mission is going after one of the most important questions in understanding the Earth's climate system, which is how does stuff we burn affect how clouds form?
Yeah, and it's really cool because in these intricate missions, you have so many team members who put in so much effort to make it happen.
Yeah, like most people think, oh, it's just a bunch of scientists, right? But you've got everything from mechanics that are keeping the plane flying, to the technicians tweaking all the instruments, all the way even through to the people who are doing things like getting the data together and putting it up on the web.
Yeah, and then you also have science writers like me, and then you have your copy editors, and like you're saying, your IT specialists. It's all this information, and we have to make it understandable for the public. And then you also have the people who have to take care of the people in the field with like accommodations and the food and the toilet paper and everything that they need.
Yeah, it's a big team, and you got to take care of them.
It is, and actually, one of my favorite team members doesn't have a pulse. It's actually the Coral Mission's G4. So let's go check in and fly like a G4.
Like we said before, NASA airborne science is all over the world, and we've got a mission continuing in the frozen north, checking out the melting glaciers of Greenland, flying out of Keflavik, Iceland. Team OMG.
I'm Josh Willis. I'm a climate scientist at the Jet Propulsion Laboratory, and right now I'm in Keflavik, Iceland, in front of the Gulf Stream 3, which we're using to conduct a survey for oceans melting Greenland. We have a series of points laid out where we would like to collect data, and by and large, we fly over those points and drop when we're right above them. However, in some places where ice or clouds are a factor, we relocate our points in order to find open water that's clear, where we know we're not dropping on top of a ship or anything, and we're able to drop through an area without sea ice. So in fact, when we have to change quickly because there's sea ice conditions or clouds in our drop point, we look out the window and look for places where we see clear open water and clear skies just above it, and we drop in those. So the team is sometimes targeting in real time, trying to find places that are close to our original planned drops, but not quite there. We've set up 4 different primary locations for collecting the observations for OMG. Because of the range of the aircraft and the way the survey plan spreads out the ocean measurements, we really have to operate out of bases that are nearby and collect data that is not too long a trip for the plane. If we spend a lot of fuel flying out and flying back, then that means we have less fuel to actually drop the probes and collect data. So we've partitioned Greenland essentially into 4 pieces, north and south and east and west. We began by surveying the southwest part of Greenland, and we operated out of Kangerlussuaq. We also dropped some probes on the way over when we flew from Bangor, Maine to Kangerlussuaq. So we flew from Bangor to Kanger. So the Kangerlussuaq was a very interesting place, but we were able to operate out of there for several days and really complete a large chunk of the southwest part of the survey, dropping several dozen probes over the course of 3 or 4 days. After picking up about 50 probes from Thule, we flew to Svalbard, Norway, a small island off the northeast coast of Greenland. From there, we were able to complete the northeast part of the survey, at least the parts that weren't covered with ice, and then flying across the northern edge of Greenland and surveying along the northern coast of Greenland on our way back to Thule. Then we spent several days in Thule completing the northwest part of the survey before yesterday flying right across the Greenland ice sheet to Iceland and landing here in Keflavik. We've set out a very ambitious plan here with the goal of dropping 250 probes in about a month. We're a little over halfway right now. We've dropped 150. We have 100 left to go and about 2 weeks left to do it in. So we're definitely beginning to feel the time crunch, but I'm confident that we can have a really excellent survey with just a number of good weather days if we can get them. Hey Tom and Kasia, I hope you enjoyed this little tour of oceans melting Greenland. I'm Josh Willis. OMG, back to you guys.
Hey, thanks, Josh. Those guys got to see some pretty amazing stuff, huh?
Yeah, it inspired us to come outside, and it's not exactly Greenland, but it's still pretty beautiful.
Yeah, but you know, it's also a good example. Imagine coming to a place like this with like a team of 24 scientists and an airplane.
I can't. And then you have all these things that you can't control, like the weather, or if like your engine fails or something like that.
Yeah, like science sometimes is just like an exercise and just keep trying, keep fixing, and keep moving on.
Perseverance.
Hey, well, that's all for us today. We hope you enjoyed this episode of Earth Expeditions.
And go outside and create your own Earth expedition.